Day 17, Agent Architecture, Planner, Executor, Memory. Day 17 is where the exam quietly checks something very important. Do you understand the difference between calling an LLM and building a system that can act? This is a conceptual jump, not a technical one. Imagine this. A massive earthquake hits a city. The government deploys an AI called the Disaster Response Commander. Its job is not to answer questions. Its job is to do things. It must assess incoming damage reports, request satellite images, check shelter capacity, coordinate supply deliveries, and keep track of what has already been done. This system cannot answer once and stop. It must think, plan, act, observe results, and remember. That is an agent. So let's define this clearly. An agent is an LLM-driven system that can plan steps, call tools, observe outcomes, and decide what to do next. A chatbot answers. An agent acts. This distinction matters deeply on the exam. If AWS mentions multi-step workflows, tool calls, decision-making, or orchestration, you are no longer in chatbot land. You are in agent architecture. Every agent, every real one, has three core components: a planner, an executor, and memory. Remove any one of these, and the agent collapses. Let's start with the planner. The planner is the thinker. Its job is to take a goal and break it into steps. It decides what should happen next. In the disaster response system, a human says, set up emergency shelters for 2,000 people. The planner does not call APIs yet. It thinks. First, check available shelters. Then calculate total capacity. Then identify shortages. Then request supplies. This is reasoning about actions, not performing them. On the exam, if you see words like task decomposition, planning steps, or deciding actions, you are looking at the planner. Next is the executor. The executor is the doer. It does not think creatively. It does not decide strategy. It performs actions chosen by the planner. In our disaster system, the executor calls real tools. It calls a GIS API to locate shelters. It calls an inventory system to check supplies. It calls a logistics service to request deliveries. In AWS terms, the executor is almost always implemented with Lambda functions and APIs. The LLM decides what to call. Lambda actually calls it. This separation is critical. Now comes memory. Memory is what prevents the agent from being stupid. Without memory, the agent forgets what it already did, repeats actions, and loops endlessly. Memory exists in two forms. Short-term memory holds the current conversation and recent tool results. This often lives in the prompt context or session state. Long-term memory stores things that must persist: past decisions, historical facts, user preferences, completed actions. This is usually stored in a vector database or a regular data store. In the disaster system, memory remembers which shelters are already full, which supplies have been requested, and which decisions are final. Because of memory, the agent does not ask for the same supplies twice. Now visualize the full agent loop. A user provides a goal. The planner reasons about the next step. The executor performs the action by calling tools. The system observes the results. Memory is updated. The planner decides what to do next. And the loop repeats. If you can explain this loop, you can answer any agent architecture question on the exam. Where do AWS services fit into this? Amazon Bedrock provides the LLM that acts as the planner. Lambda functions act as the executor. Vector stores or databases provide long-term memory. CloudWatch and X-Ray give you tracing and observability. IAM controls which tools the agent is allowed to use. If the exam asks how an agent interacts with external systems, the correct answer is the LLM plans. Lambda executes. Now, it's equally important to know when not to use an agent. Agents are powerful, but they are expensive and complex. They are good at multi-step workflows, dynamic decisions, and tool orchestration. They are bad at simple question and answer tasks, static responses, or one-step jobs. If the problem is simple, an agent is the wrong solution. AWS penalizes over-engineering. Finally, watch for the exam traps. An agent is not just a bigger prompt. Agent memory is not only chat history. Tools are not called directly by users, and agent logic does not live entirely in Lambda. The correct mental model is simple. The LLM decides, the executor acts, memory persists. Here is the one sentence to lock this in. The planner thinks, the executor acts, memory prevents stupidity. Say that once before the exam. Final self-test. A system must decide which APIs to call in what order and remember previous results. What architecture is required? An agent with a planner, executor, and memory. That's day 17 mastered.